Welcome back. Have you ever wondered what happens behind the scenes when you upload a video to YouTube? How does it transform your raw file into seamless viewing experience for millions of users? Today we are diving deep into the centralized architecture of YouTube's video upload workflow. So let's imagine that you are in a system design interview and your interviewer asks you, please design YouTube. How should you respond to that? The first thing we need to know or we need to do is to basically try to understand the problem and know our functional requirements and non-functional requirements. So for this video, the functional requirements, it will be 6 things. We need to have a system that stream videos, upload videos, search videos according to titles, like and dislike videos, and comments to the videos, and also to view thumbnails. And the non-functional requirement, we need scalability because as number of user grows, these issues should not become bottlenecks like storage for uploading content, the bandwidth required for simultaneous viewing, and the number of concurrent user requests should not overwhelm our applications at all. The second thing, high availability. The system should be highly available. High availability require a good percentage of uptime, generally up to 4 nights, for example. Also, we need to have a good performance, like a smooth streaming experience leads to better performance overall. And lastly, reliability. Content uploaded to the system should not be lost or damaged at all. Okay. So let's start to make the architecture of our system. And as always, everything starts with a client. So we have our client. And I need to make this like that, and the client will send the request to API gateway or a server, like you can call it whatever you want, but I prefer to use the term of API gateway. The API gateway, the servers acts as a first point of contact of users. They handle user requests, whether it's uploading a video, streaming content, or interacting with metadata. The responsibility of it's processing requests, server process the uploads, search queries, and other user interactions. It will validate, they ensure that upload content meets platform guidelines like format, size, etc. It also forward requests to other components like encoders or the database. An example for that, like when you upload a video, the server received the file, extract the metadata, and routes the raw video to the encoder for further processing. So we have the API gateway, and next we have the metadata. Give it different. We have the database, for example. The database, let's call it the database. This database will store user data and metadata. The database stores all metadata related to videos, users, comments, and thumbnails. The responsibility for this database, it will be pretty simple. First, it will have stores videos, titles, descriptions, tags, user information, and comments with metadata related objects. Query handling also, so it will handle queries related to search, recommendations, and user interactions. Also, it will have some sort of real-time updates, like it will support real-time updates such as adding likes or comments or updating video views. Like when you search for video, the database retrieves relevant metadata such as titles and descriptions to display accurate search results. The next thing we need to talk about, which will be the encoder. Encoder. Okay, encoders and transcoders process raw videos files, compress them, and convert them into multiple formats and resolutions. Like the responsibility of it, first it will have a multi-format conversion. It will convert videos into resolutions like 720p, 1080p, and 2160p. To accommodate different devices and internet speeds. It will also have some sort of compression. It will reduce the size to optimize the storage and streaming bandwidth. Also, it will have some sort of device optimization. It will ensure videos play smoothly on a variety of devices from smartphones to 4K TVs. And yeah, this is the point of using encoders. Next, we have what should we talk about next? A blob storage, and this is the most important one. I would say this is the backbone of the system. Let's call it blob. Blob storage. The blob storage is secure, stores raw and processed videos file. The responsibility of it, it's a scalable storage, handles massive volumes of videos data, both raw uploads and encoded files. It will ensure fast access to video files during playback. It will have a redundancy, so it will store multiple copies of videos across regions to ensure availability and reliability. After encoding, the videos files are stored in blob storage. These files are later fetched for streaming by users. Okay, what should we have next? I guess we have here the API gateway, the database, and the blob storage. I guess we should have, let's put the blob storage here and put it like that, and I could make this like that. I could give it different color, I guess if I give it different color, it will be better, to be honest. Black, and this one will be like, yeah. And let's give database also different color. And the encoder as well. Okay, so I guess next we need to talk about the CDN. CDN. And let's give it like and let's see. Okay, so the CDN or a content delivery network, the CDN caches popular videos close to users geographically to reduce latency and server load. The responsibility of the CDN, it will basically it's caching popular videos. It will store frequently accessed videos for faster delivery. It will reduce latency. It will ensure smooth playback by delivering, by delivering a content from servers closer to the user. It will also distribute traffic to prevent overloading central servers. So yeah, and let's. And yeah, the API gateway also will distribute the load among multiple servers. So yeah, it will to handle load balancing. It has some sort of load balancing responsibility as well. Do we have to talk about anything else? I guess like for an initial overall, I guess we don't have to talk about anything. This is a high level design of the system. And in the future videos we'll try to tackle every section one by one, but we can go through the videos upload workflow. So first, everything starts with the client. The client will try to upload the video. So when you upload the video, it sends to the centralized servers or our API gateways. This server acts as the gateway to entire process. After that, we store all the metadata. The server immediately extracts metadata like the title, description, and user information and stores it in the database for easy access. After that, we handle the video, handling the video to encoder. The raw video file is handled over the encoder, which compresses it and converts it into multiple resolutions like 1080, 720, and 480. Number four, we have to the storing videos in the blob storage. So this section number four. The process videos files are then saved in blob storage. This ensures the original and encoded files are securely stored. And lastly, we have the CDN. So if a video becomes quite popular, it's copied to a content delivery network, ensures users can stream videos with minimal latency, no matter where they are in the world. So yeah, why? Let's understand why the API gateway is quite essential in this workflow. There are three reasons: the security, because the server protects the encoder from malicious upload; also the the deduplication, because it prevents duplicate videos from being processed. Also, it have some sort of access control, like encoders operates on private networks, ensuring they are secured and efficient. If we want to talk about some sort of enhancing the user experience, the encoding will play a crucial role in ensuring a seamless user experience, like by compressing files and converting them into multiple formats. YouTube ensures that videos are optimized for all devices and internet speeds. Do we need to talk about anything else? I guess will be like a high level starting video. In the future, we will create a lot of different videos that talks about the system in details, like how does the encoding schema enhances the user experience. Should the compression be performed at the client side or the server side? The building upon and also we can build upon a high level system to talk about some other things like using big tables or using temporary storage for updates. And we also will improve our system. This is not the end for our system. We will add a lot of different components, but this is a starting point for our YouTube system design video. So that's it for this video, and see you in the future.